Hello and good morning everyone. My name is Nur Alisha binti Muhammad Rosmaili and with my group members.
I am Nur Fakira binti Muhammad Shahidullah.
My name is Nur Hanuzati binti Muhammad Shafi.
Today we will be presenting our final year project for DPEX, which stands for Dissertation, Presentation and Exhibition, titled Utilization of Various Types of Used Cooking Oil as Flow Cleaner.
Pour grease down your sink. It can mix with other waste materials like wet wipes and diapers, creating a blockage. As the mass grows, it clings to the sewer walls, forming a hard rock-like substance. Over time, these fatbergs can become enormous, blocking pipes and causing sewage to back up. And they can grow so large that workers have to manually break off pieces with shovels until it's able to be removed.
As you can see in this video, this is what usually happens when people throw used cooking oil into the sink. It can cause clogged pipes, unpleasant smells, and even water pollution. Nowadays, there is a growing concern about the negative environmental effect caused by chemical-based cleaning products. Most commercial flow cleaners contain synthetic surfactants and harsh ingredients that not only pollute the water but also affect human health when used over time. At the same time, used cooking oil is one of the most common types of household waste. Many people dispose of it directly into the sink or drains after cooking, which can lead to serious problems such as clogged sewage system, foul smells, and water pollution. Realizing this issue, our project focused on recycling used cooking oil into an eco-friendly flow cleaner. In this study, we used three types of used cooking oil: palm oil, corn oil, and sunflower oil to determine which type performed the best. We processed the oil through saponification and emulsification and later added essential oils to enhance the fragrance. This study aims to prove that waste materials can be turned into useful and sustainable cleaning products, while reducing pollution and promoting the concept of circular economy where waste is repurposed instead of discarded.
For the problem statement, the management of used cooking oil in Malaysia still faces many challenges. Most households simply dispose of their used oil into the sea, which causes clogging, soil contamination, and also water pollution. So, moreover, some vendors reuse the same oil multiple times to save costs. However, this action causes repeating heating process that leads into formation of harmful compounds that are toxic and can lead to long-term health effects. Although recycling program exists, the level of public awareness and participation remain very low. In most cases, used oil is either thrown away or exported overseas to process into biodiesel. So, because of this, our group wanted to explore more about local, sustainable, and also practical solution by converting this waste oil into a functional household cleaning product. So this not only will reduce the pollution but also can encourage a more sustainability lifestyle within the community.
Next, I will explain the objective of this study. There are three main objectives. First, to utilize used corn, palm, and sunflower cooking oils as raw materials to produce a floor cleaner. This helps to reduce waste oil and promote recycling. Second, to analyze the quality of the floor cleaners based on physical, chemical, and biological tests according to the Malaysian Standard MS 1526/2014 to ensure the product. For the last objective is to evaluate the cleaning efficiency of a floor cleaner from used palm, corn, and sunflower cooking oil. This project aims to determine how effective the floor cleaner is at removing dirt and stains after being produced from different types of used cooking oil. For the scope of study, this project focused on the collection and utilization of used cooking oil from both household and food vendors. The oil samples were pre-treated using bentonite clay to remove color, odor, and impurities before being used. The floor cleaner was produced through saponification and emulsification processes using potassium hydroxide. After production, all samples were tested based on Malaysia Standard MS 1526/2014, which include several parameters such as pH value, solubility, rinsing properties, cleaning efficiency, and microbiosafety. The scope of this research ensured that our project focused on measurable and practical aspects to confirm that the product meets both safety and performance standards.
The significance of this study lies in the environmental social impact. By reusing used cooking oil, we can help reduce pollution and also minimizing waste and promote sustainable and management. This project support the idea of green economy, where household waste is seen as not as a problem but resources that can be used creatively. Moreover, this research aligned with the United Nations Sustainable Development Goals (SDG), especially Goals 12, which is responsible consumption and also products. So, in addition to that, it creates public awareness about proper waste management and promote eco-friendly product innovation.
Next, I will explain about our target group. For this project, we focus on three main target groups: household, small food vendors, and local industry or institutions. First, for household, they can reuse their own used cooking oil to produce a flow cleaner at home. This helps reduce household waste, save money, and prevent oil from polluting drains and rivers. Second, for small food vendors, our project provides a sustainable way to manage and recycle their used cooking oil safely. It helps reduce waste generation and promotes environmentally responsible business practices. Lastly, for local industries and institutions, this project supports Malaysia's effort towards green technology and the circular economy. It also helps raise public awareness about the importance of proper waste oil management. So overall, our project benefits different levels of society, from individuals at home to larger organizations, in promoting sustainability and responsible waste management. Next, I will explain about the materials and equipment used in our project. For this study, we use three main categories: chemical, reagent, oil materials, and equipment. First, under chemical reagent, we use soda ash, sodium silicate, and cocoa betaine. These chemicals were used during the saponification and emulsification process to help form the flow cleaner solution. Second, under oil materials, we use sunflower oil, palm oil, and corn oil. These are the three different types of used cooking oils we selected to compare their performance in producing the flow cleaner. Lastly, for equipment, we use a beaker, hot plate, pH meter, filter paper, thermometer, and magnetic stirrer. All these tools were used to heat, mix, test, and measure the properties of the final product accurately.
The flowchart shows the overall process of how we produce the flow cleaner. First, the used cooking oil was filtered using filter paper to remove impurities and solid particles. Next, potassium hydroxide was added to the oil to start the saponification process, which formed a soap paste. After that, the soap paste was diluted with distilled water, and we add cocoa betaine, sodium silicate, and soda ash to improve the cleaning and foaming properties. Finally, essential oil was added to enhance the fragrance of the final product. Once all ingredients were fully mixed, the flow cleaner was left to rest and stabilize before proceeding with physical, chemical, and biological testing. We carry out three physical tests, which is pH value, solubility, and rinsing properties according to MS 1526-2014. For the pH test, all three types of flow cleaner recorded values between 10.3 and 10.5, which are within the acceptable standard range, not less than 4.5 and not more than 10.5. This means our product is not too acidic or too alkaline, making it safe for use on different flow types.
For this test, we wanted to check how easily the flow cleaner can be rinsed off after use. We tested three samples. The flow cleaners made from used corn oil, palm oil, and sunflower oil. The method used was based on the Malaysian Standard MS 152C 2014 for flow liquid detergent specification first revision. In this test, 5 ml of product was mixed with standard hot water to make 100 ml of solution. The mixture was stirred at 27 degrees Celsius for 5 minutes and then inspected to check for any undissolved material. The results show that our product was free rinsing, which means it can be rinsed off easily without leaving residue on the surface.
The product was found to be a free rinsing when tested as specified in Annex C of the Malaysian Standard MS 1526-2014, which is flow cleaner detergent specification for first revision.
Next, I will explain about the cleaning efficiency test. For this test, we use 4 types of stains: butter, soy sauce, turmeric powder, and food stains. The purpose of this test was to compare how well the flow cleaner made from used cooking oil can remove these stains compared to using plain tap water. From my observation, the results show that the flow was cleaned more effectively after using the used palm oil flow cleaner than when using tap water only. This proves that the cleaning produced from used palm oil has good cleaning performance and can effectively remove common household dirt.
For the sample produced from used corn oil, the test results show that the corn oil cleaner was able to remove all stain effectively, especially oily and greasy stain like butter and turmeric. It produced a clean, shiny surface and left no residue after rinsing. The product also had good stability and pleasant fragrance, showing that corn oil is a suitable raw material for producing an efficient floor cleaner.
For sunflower oil, it was efficient as the commercial floor cleaner, and it's also we have compared it with tap water, which is on the left, and the right side is the tap water plus the floor cleaner.
In conclusion, the overall physical analysis for all three types of used corn, palm, and sunflower oil made the Malaysian Standard MS 1526-2014. All the sample had pH values within the safe range, were fully soluble in water, and show excellent rinsing ability. This confirmed that the flow cleaners made from used cooking oil are physically stable, safe, and effective, and can be considered as a sustainable alternative to commercial chemical-based flow cleaner.
For biological analysis, which is the microbiological test for Escherichia coli, we sent all flow cleaner sample to UNIPEC, University Kebangsaan Malaysia, for testing. The results show that for used cooking corn oil, the E. coli value is less than 3 mpn per gram. For used cooking sunflower oil, it is also less than 3 mpn per gram, and for used cooking palm oil, it is less than 3 mpn gram as well. This means no E. coli bacteria were detected in all three samples. Therefore, all the flow cleaner products are microbiologically clean, non-hazardous, and safe to use.
For this part, we conducted a heavy metal test focusing on lead. The purpose of this test is to ensure that the reused cooking oils we use are safe and not contaminated with any toxic substance. From the result, all three samples show very low levels of lead. The sunflower oil sample recorded 0.011 mg per kg. The corn oil sample 0.020 mg per kg, and the palm oil sample is 0.015 mg per kg. All these values are below the harmful limit, which means the materials we use are safe and suitable for our project.
So, in conclusion, this study successfully demonstrated that used cooking oil can be efficiently repurposed into a safe and high-quality environmental-friendly floor cleaner. So, through physical, chemical, and also biological testing on the Malaysian Standard 1526-2014, the formulated cleaners show that acceptable pH, good solubility, and also effective cleaning performance. Hence, the project proved that sustainable innovation can be achieved through simple yet impactful approaches.